So hello again, everyone. And today our event will be with Ikdem Ben Mbarek. So maybe we start by presenting SHA and what we do. So actually, Social Hackers Academy is a non-profit organization founded in 2017 in Athens. Our main objective is to democratize access to education and the labor market. We offer scholarships to migrants, refugees, and unemployed people. And we recently, as I already said, we started our 16th class of our free front-end web development career track, which is fully online. We host a minimum of 2 events every month for our students and for anyone interested. And one of them is hiring related, where we discuss topics for anybody trying to get into the tech industry. And the second one is a technical event like this one that focuses on a topic on web development and a new technology. So my name is Slim Kasraoui. I'm from Tunisia. I'm the tech education lead at Social Hackers Academy. And so how about you, if then maybe you can present yourself and today's topic.
Hello, can you hear me?
Yes, we can hear you, but
Can you see me now?
now we can see you.
All right, very well. Okay, Slim, thank you so much for this introduction.
Thank you for being with us today.
Thank you. So it's a big pleasure to be here with you guys. Actually, for those who don't know, Slim was my student before.
Yeah.
Yeah, Slim studied IT. He studied full stack web development at a boot camp in Tunisia called Rio Boot Camp. So as you can see, like coding boot camps work, okay? They can work. They can produce full stack developers that are ready to market and ready to job. So in case you are wondering if you can find your job or you can land your job, or is it possible to learn that in 3 or 4 or 6 months? Yes, it is possible, but it depends on you, okay? But because like many people studied with Slim and they are still looking for their first job right now, okay? So it all depends on you, okay? So coding bootcamps are just a way, are just a path. They are just a step in your life journey. And as every step, as everything you go through in life, as every experience you encounter in your life, it depends on you, okay? The outcome depends on you in the end.
And the outcome depends on the input you put in. So it's like the database. You get what you put. So as much hours of work you put, as much commitment, that's what you get in return.
Yeah, yeah, fair enough. All right, so my name is Ikdem Ben Mbarek, as Slim said, and I'm a full stack JavaScript developer. I'm a computer science engineer. Currently, I'm the CTO of a Tunisian startup specialized in fintech and online payments. The name is Connect, and yeah, and I'm a part-time faculty member at a part-time professor at a Tunisian university called Mediterranean Technology School. And when I was invited here to be among you, we thought about doing a workshop, like a live workshop on how to deploy our applications. Okay, so we wanted to try something new, something you didn't encounter before. We were trying. Actually, don't see my screen right now, so let me share my screen. Yeah, I do. Okay, Mr. Host, can you
Yes.
allow me to share my screen, please? Okay, so the aim of this workshop was to like do a live coding experience and deploy an application on deploy an application on a platform called DigitalOcean, but for some reason, DigitalOcean is not allowing me now to enter my account. It's telling me that it sent me a 6-digit code, but I can't find it anywhere. So yeah, we're gonna do something else, but something more fun actually. Okay, I'm gonna ask a question that any full stack developer, any developer should be able to answer. Okay, if you can answer it, that's great. You are on the right path. If you can't answer it yet, try to focus, try to pay attention, because it's, as I said, it's very important. So the question is, how does the internet work? It's a very simple question that a curious 5-year-old child can ask. A curious 5-year-old kid can ask. But did you ask yourself this question before? Like when I go open a browser, a software called a browser, and I write down autodraw.com, I end up with this web page. How does that happen? So Slim, is the session interactive or should I carry on?
As you wish. So if you want it to be interactive, we can interact with the students. So you can, the students or the attendees. And I was thinking about the students because this was today's session's topic for our new class. So I was thinking that maybe some of them can tell us what they learned today in the session.
All right. Let's see if you were paying attention today.
Yeah.
Okay, let's go ahead.
So,
Anyone who wants to participate? Anyone who wants?
Yeah, you can write down in the chat or just raise your hand and we can make you panelist so you can interact with us, like with your audio and video.
Mm-hmm. Yeah, I see a hand raised there. It's Konstantinos. I hope I'm pronouncing the name correctly.
All right. So it's Konstantinos, I think.
Yeah.
So we're gonna allow Konstantinos to talk. I think you can talk now, Konstantinos.
Can you hear me?
Yes, very well.
Hey, good evening. How are you?
I'm doing great, thank you.
Nice to meet you.
Thank you so much.
So, the question: how does it work? Let me see. The internet works through HTTP protocol.
HTTP protocol, yeah, that's very important.
Yes, which is a protocol that connects IPs. I think so.
IPs, like IP addresses.
Protocols from computer to computer.
Yeah.
I try to say in my own words. You send a request, like the name of the site, which is a binary code in IPv4 or IPv6, but the DNS translates it to the name of the site.
Yeah.
And the server of the site receives the how you say the call, sorry, I can't find the word.
The request, maybe.
The request, sorry. And it responds you back with the HTML code and the other things, and your browser renders it to the site we see.
All right. I think he was paying a very good attention to today's lecture.
I tried my best to say it.
That's
all
great.
Right, yeah, it was.
We have also Lauren in the chat saying it's basically a lot of LAN connected with each other, the bounds of nodes connected.
Yeah, that's basically it. So if you think about the internet is called the network of networks. So it's a network. So we have here a node and another node and another node and another node and another node. in another node, and they are all interconnected. Okay, so they are connected to each other. It's the network of networks. So here we have a network, we have other nodes, we have a network, and here we have another network, and here we have another network. And all the networks are interconnected, they are connected together, and they can exchange things, okay? The things that they exchange what was the name again? Konstantinos, yeah. How can I erase?
Or maybe learn.
Yeah, he said HTTP.
So Konstantinos.
Yeah, so we can, these devices, like the nodes are nothing else than devices, okay? These are routers and switches, and we have the end machines, devices. They can be mobile phones, they can be laptops, they can be, I don't know, cars, they can be smart objects, they can be anything that is connected, that is able to connect to the internet, all right? And they exchange data through HTTP, through a protocol called HTTP, Hypertext Transport Protocol, okay? So HTTP, so each device that is connected to the internet will have an IP address, okay? How can I delete? All right, we'll have an IP address. Let me refresh. All right, a new one maybe. An IP address is like the address of that device. So if you want to connect to exchange data or to talk to that device, you should use you should send them data on its IP address, okay? But us humans, we're bad at remembering things, and actually, even if you are good at remembering things, we won't be able to remember or to remember all the IP addresses. It's like, for example, how many websites did you visit today? How many people did you chat with today? Hundreds. Like, we visit hundreds of websites every day, if not more. So if I'm gonna visit a website, I'm gonna find it hard to remember the IP address of any website. So I'm visiting Facebook and then Instagram, and then I'm gonna study on SHA website, and then I'm gonna send an email, and then and then So I won't be able to remember like the IP address of SHA website is 1, 2, 3, 4, 5, 6, etc. Okay, and IP addresses are not even easy to remember because they are just a group of numbers. They are just a group of numbers. So if you look at the IP address format, we have two main formats, the IPv4 and the IPv6. Okay, so if you look at the IPv4 format, you will find a group of numbers. So imagine that you, as a human being, as a lazy and a lazy human being that doesn't have a good memory, and that you are asked to remember thousands of things every day, and then they ask you, hey, if you want to use the internet, you should remember these numbers. Okay, I want to go to google.com to make a search. I need to enter these numbers. I want to go to SHA, another number, right? Another 12 to 16 digits number. Okay, that's very hard, that's very tedious, okay? So the people behind the internet, the early people that designed the internet, think about a solution for that, all right? So back in the days, the solution was to have a table, all right? A table on your computer, a file on your computer, in which, let me make this bigger to have a bit of space. A list of, let's say, IP addresses. So you have in your table, you will have google.com and then the IP address of google.com. And then you have facebook.com and then the IP address of facebook.com. And then you have sha.com and the IP address of sha.com. So you will have them stored in a table, okay? In a file, in a text file or in a table file. But with time, the internet had a very, very big boom, okay? This was possible when we have dozens of websites available for people on the internet, all right? But with more people coming into the internet, to use the internet, more people creating new websites, more websites being available to people, it wasn't easy, and it wasn't possible even to store all these IP addresses in one file or on your device. Okay, it will consume a lot of memory. So that's why, and even if we could do it, it will take time to find the IP address every time you want to go to a new website. Okay, so to simplify this, or as a solution for that, people came up with something that the student mentioned, and its name is the DNS. All right. The DNS stands for Domain Name Server. Okay. Domain names are the names of the websites like google.com, facebook.com, sha.com, amazon.us, amazon.uk. They are called the domain names. Okay. And the DNS is a server. Okay. It's a machine that is somewhere here on our, somewhere here, we have a DNS server. And the DNS is a machine, a laptop, that is connected to the internet and that is available to anybody to send requests to. Okay? So when you send a request to google.com, when you type google.com in your browser, what happens is that you send a request through here. Let's say you are here, send a request to the DNS server. Okay, of course, the routers, there are plenty of routers here and there, and they redirect you. Each router will redirect you to the route. A router is just like a policeman standing in the way, telling you, hey, where do you want to go? Yes. Okay. So you gave him the IP address, and he tells you the way. Okay, he transmits you to the other router, and then to the other router, and then to the other router, until you reach your final destination, which is the machine that has that IP address. Okay, so when you send, so now we don't need to store hundreds of thousands of IP addresses, of millions of IP addresses. We just need to store one IP address of the DNS. Okay, of the DNS server. So we will send the request to the DNS server. All right. The request will hold the domain name, which is, in our case, Google. All right. So we will send google.com to the DNS server, and the DNS will send us back the IP address of Google. So it's just doing the same thing that was done in our computer, but instead of slowing our computer down, and instead of storing hundreds of millions of IP addresses and domain names, we could just save the IP address of the DNS, send the request to the DNS, and the DNS will get back to us with the IP address. Okay? So next, so here, of course, we typed google.com in the browser. So first step is to send the request to the DNS, get the IP address from the DNS, and then send the request to the IP address that we got from the DNS server. All right. So we will send the request. So when you type here google.com, actually you can inspect and see what's happening behind the scenes. So you can inspect in your browser and open the developer tools, as you can see here. We can see this tab called network, and network will give us an overview of all the exchange, the responses and the requests going on and out from our browser to the internet. Okay, you can filter by the type of the the requests. Okay, so if you are requesting a file or an image or a media or a font, etc., or you are fetching data. In our case, we are fetching data. Okay, or you can just see all of them. Okay, in our case, we are fetching data. So we are sending a GET request. It's a POST request. Let me refresh. All right, so these in red, they have errors, okay? Status code 400 is for an error. All right, there we go. We have a GET request sent to google.com/complete/search client is web, all right, etc. Okay, so google.com, we send the request to google.com, and we got back a response preview. We can see the response, etc. Of course, here we can see like the response because it's files. It's a web page. All right, and you can find all the information about your request. So we sent a request to the server, and we got back a response from the server. All right. Okay. We sent a request, of course, to the IP address because now we had this IP address. This is the IP address that we got back from the DNS server.
We have a question from Constantinos, and he's
Yeah?
asking who owns the DNS servers.
That's a good question. Actually, there are many DNS servers. You can just type DNS servers. There's a DNS servers, for example, a DNS server hosted by Google, for example, and I think its IP address is 8.8.8.8. Yeah, it's for Google developers. See, a Google public DNS. So anyone can make a DNS server, anyone. But of course, it's not interesting for everyone to have a DNS server. So companies, like you can find here the full list, public DNS servers list. And you can find them all here, for example. This is the IP address, the location, the version, and the who is will give you who owns that server, who owns that IP address. All right, so this one is owned by ATM SA. It's an organization, it's not an individual. Okay. All right, I hope that answers your question.
Yes, thank you, Ikdem.
All right. Okay, so going back now, we send the request to google.com. So the request is an HTTP request, and the response will be an HTTP response. Meaning that it's a response and a request that follow the standard, the protocol of HTTP. All right. The protocol of HTTP contains many things. Okay, many things, like the format. Okay, how the data is structured, the headers, many things, many things. Okay, so if you want to dive deeper into that, you can read about HTTP protocol, its format, like the HTTP request, how is it formatted. Like you will find that you need to allow or allocate 4 digits for the headers, 4 digits for the methods, 16 digits for the data, etc., etc., etc. Okay, so the architecture of the web is a client-server architecture. Okay, and we will have here a client, and we will have here the server. So who can tell me who is the client in our architecture and who is the server? Can any one of you answer this question?
All right, so we have some hands.
All right, let's hear it.
we was having two hands. Now only one is remaining, and it's again Konstantinos and Thomas. So maybe this time we're gonna take Thomas first.
Yeah, give us Thomas.
All right, so I'm promoting Thomas to the panelist. So hello, Thomas. You can unmute yourself and maybe answer.
Thomas, you are on mute. We can't hear you.
I think he asked the question in the chat. So if anyone can own the DNS server, is there a danger to publish wrong IP addresses to domains?
And
then he said, yeah, sorry. And then he said our browser is the client.
Okay. All right. So you got it right. So for the question, sorry. Of course, you're not going to send the request to a random DNS server, okay? Every internet service provider, all right? I don't know, like you can have Vodafone, you can have AT&T. I don't know what kind of service providers you have in your country, but for example, here we have Ooredoo, okay, in Tunisia. So in Tunisia, Ooredoo has a domain name service that they are working with. It can be their domain name service. It can be someone else, okay? And of course, you can customize, you can change it. You can go to settings on your computer. Anyone can do that. Check this, settings of the Wi-Fi, okay? You'll find here IPv4. And here I specified the DNS. You can put it to automatic, okay? So the service provider will have a list of DNS servers that he trusts, okay? And of course, they will be trustworthy. And he will send to the first one. If it doesn't respond, he will send to the second, third, etc. Okay? Because putting one is dangerous. It's like a bit dangerous, maybe. Although, like, it's very, like here I'm sending to Google, okay? Although, like, it's very, very not common to have Google servers shutting down or something. Here I have another one. I think it's Google as well. It's a backup from Google. Let's see. Yeah, it's the secondary DNS server for Google, public DNS. All right. So Google already has two, like one primary and one secondary. Okay. So there you go. You don't have risk to trust the DNS server because it's trustworthy. Trust me, I'm trustworthy as well. Okay. So you said that the client is the browser, and yeah, that's right. In our case, in my laptop, yeah, the client is the browser. The client can be an application, a mobile application, okay? So for our example here, for my laptop, for my current situation, yes, it's the browser. It's not the whole machine, but it's just the browser, because the browser is the software, is the client that is sending the requests and getting back the responses, all right? It can be a mobile application if I'm using my mobile, for example. It can be a software installed inside a smart car, for example, okay? Or a car that has an operating system, okay? It can be a smart camera, all right? But for our case, it's the browser. And the server is, as we said, just a machine, a device, sitting there in the internet, waiting for people with requests to give them back responses, okay? So back in the days, like at the beginning of the internet, if you wanted to have a server, you need to buy a machine or use your machine, your own laptop. Of course, there were no laptops there, so your own personal computer. Run the application on your computer, run the website on your computer, and start listening for people, expose it to the world, give your IP address to your friends, and start waiting for people to start sending you the request. Start waiting for browsers to send you the request, all right? But there's a good chance, and of course, by the 80s and 90s standards, there's a good chance that your machine was going to explode because it wasn't that performant, first. And second, it was going to heat up until it turns off or explodes. So the solution is to have special machines like that come with no screen, with no mouse. We don't need that. We just need to connect to those machines, put the website there, and keep it running. Okay. So at first, every person or every company that wanted to create a website, they had to buy that machine and put it somewhere inside the room or somewhere inside the company. Okay. So you will have a room in the company specialized for servers where you can find the machines running 24 hours, 7 days a week. Okay. But with time, people started looking at things differently. All right. They started like now we can have service providers like DigitalOcean, the one that didn't work for us today. We can have now service providers or Oridu. You can contact them, buy a machine from them. They will have a whole data center that can be, for example, in Norway or in Russia or somewhere cold in the world. All right. You can contact them. You can buy from them a small machine inside that data center. They will give you access to it through something that we call, for example, the SSH, not the SHA, the SSH, which is a way to connect to servers, to remote servers from your local machine. All right. So from your terminal, you can connect and run commands from your terminal, from your computer, and they will be executed in that remote server. So, or they can give you even panels like cPanel, if you know it. If you want to host a website, some service providers, they give you access to some panels, some dashboards that you can use to host your website easily. All right, so you can open it, create a database with MySQL from here, and add your web pages, and there you go. Your web page will be ready. Okay, your website will be ready. Of course, you can use for this another type of requests, not the HTTP requests. For hosting websites, we can send our data, we can send our folders, our web pages in HTML, CSS, and JavaScript format. We can send them in FTP. We can send them through the FTP protocol, which is the file transport protocol. So you are sending a file from one device to another. Okay, so instead of using a USB key or a hard drive or storage or like a device for that, you can use FTP, file transport protocol, and your file will be transported through the internet. Why we don't use HTTP? Because HTTP are a bit limited when it comes to this, because the data that you can exchange with HTTP is very limited, all right, the amount of data. But here we are talking about files, all right? We're talking about HTML and CSS and JavaScript files. We're talking about images. We're talking about videos, right? So all of that is handled through the FTP protocol, file transport protocol. And there are plenty of other protocols used in the internet, and each protocol is specialized for something, all right? For some the SMTP protocol is specialized for emailing, right? So it's the mail transport protocol, right? So when you send an email, it will be sent with this protocol, not with HTTP. Okay, and there are plenty of other protocols with separate use cases, as I told you. All right. So, do you have any questions so far? Yeah.
Yes, and here we have Thomas saying that the same way? It's a question. So is it the same way that we use Apache for PHP sites locally?
Apache is a web server. It's not like SSH. SSH is like a tool to communicate from your terminal to the device, to the machine, to the remote machine. But Apache is a web server, right? Apache is the web server that you run your application, like to run your application with, right? So it's necessary to run your application, not to communicate with remote servers.
Then he added, I mean, XAMPP, for example, is that easy?
Sorry?
So he meant XAMPP, for example, and he's asking if it's easy. I'm not sure what you mean, Thomas, by is that easy?
The question was XMPP, like this? I don't know, man. I'm not aware of this. Let's take a look at it together.
XAMPP.
XAMPP. Ah, XAMPP. All right, XAMPP. XAMPP is, all right. So there you go. XAMPP is a stack. Like, I don't know. I think you're in SHA, you are learning React, which is a part of what we call the MERN stack. All right, the MERN stack. The MERN stack is composed of MongoDB for databases, Express for the web application, React for the client side, front end, and Node for the backend. Okay, and then you have another stack called the mean stack. So they are all full stack means, like they are all used to develop full stack applications. We have the mean stacks that just substitutes MongoDB, React with Angular. Okay, so it's MongoDB, Express, Angular, Node. Okay, so you have 4 separate pieces of technologies combined together. They can create full stack applications. Back in the days, JavaScript wasn't so popular. We didn't have something called Node.js, so JavaScript was only the whole mission of JavaScript was to be run in the browser. We could not run JavaScript outside of the browser, so that's why we could not create JavaScript server-side applications. Okay, so when you can just use JavaScript in the browser. You cannot use it elsewhere. Okay, so but to have full stack JavaScript application, we need to have JavaScript in the browser and out of the browser in our server, because our browser is going to send the request to our server, and our server will process the request and send back the response. So we couldn't have JavaScript here in the server. We can only have it in the browser. So then we had, like back then, since we didn't have Node.js, we had other stack of technologies, as XAMPP, for example. All right, XAMPP stands for X could be like XAMPP. Like we have two separate things: LAMP and XAMPP. Okay, LAMP and WAMP. Sorry. So LAMP is Linux. All right, Linux, Apache, MySQL, and PHP. Okay, LAMP. So it was very popular because these pieces of technologies, they can work together very well, like the mean stack now, like the MERN stack, like the Maven stack with Vue. Okay, so LAMP was composed, the stack was composed of these technologies. All right, now it's not that popular because PHP is losing its popularity. PHP is not keeping up with the new technologies, the new trends. So this was very popular, and then PHP was substituted with Perl, another programming language called Perl. Okay, so you could do full stack application with LAMP, and Apache was the web server to run the application. Okay, so Linux was the operating system in which you create your application. Apache, the web server, MySQL for the database management system, and PHP, the programming language to create your application. All right? So you have LAMP and you have WAMP if you are on Windows. So Windows or Linux. All right, so this was the XAMPP stack. It was very popular back in the day. It's like it's a big shame to see it dying now. All right, so yeah, so we were talking about connecting to servers. Okay, and then came another trend. Okay, because we keep on improving. So the server here, as we said, was just a small machine inside the data center. All right. Then people came and said, so just to wrap up, before we had to put the device in our room, like we had to. There was no service provider to take the device from. Okay, so you had to buy the device, you had to buy the server, put it in your room, put it in your house, host the website on it, and leave it there. So even if you don't use the website anymore or you don't need the server anymore, it will stay there. You need to get rid of it, sell it, I don't know, sell it. But now you can rent. Now, instead of buying a server, you can rent a server. All right. You can, okay, I'm going to host my website and I'm just going to need 1 gigs of RAM and I don't know, 2 gigs of storage. That's what I'm going to buy. I'm not going to buy more than that. Okay. I'm going to rent that. So I'm going to rent it for 1 month. Then if I'm going to still be using my website, still be hosting my website, I'm going to rent it for another month, etc. Okay. Now with solutions like AWS and like Azure, you can you can even rent the storage and the computing power that you're going to need. Okay. Now, for example, so the leading companies in this are AWS is the first in terms of hosting, and we have Azure from Microsoft Azure, and we have Google Cloud. Google Cloud from Google. All right, and we have many other ones. I think some of them you study in SHA. You encounter things like Netlify. You can find things like DigitalOcean, like Linode. So there are plenty, and there are even some local ones. You can find a local one on like in your country. Like you can find a service provider in your country. So AWS, Azure, and Google Cloud Platform. So these solutions, like especially AWS, it doesn't just rent. It's not just there to rent things from. Okay, they can ship you the device, the machine, with things installed on it, with service installed on it. All right, they can ship you many kinds of machine. They have, for example, a service called S3, which is like Google Drive, right? S3 storage is just for storing data. So you can you can connect to it, right, through code, not through dashboard or something. You can, from your application, you can send requests to your S3 bucket, like we call them buckets. You can send requests to your S3 bucket and store data there, right? You can send data and store it there, and it will give you back the URL, so you can use it in your website, right? Or if you have photos that you're going to use in your website, you can rent an S3 bucket from AWS, and put all the images and videos there, because otherwise they're gonna slow your website down. And instead of referencing the images from the website, from the directory of the website, you can reference them with the URLs. Okay, they have something else called the EC2, which is elastic computing. So EC2 allows you to first pay as you go. So you pay what you consume, all right? And two, it allows you to first make your consumption elastic. All right, let's think about, I don't know, Thomas just created a website, just graduated from SHA, he's starting his own startup. Let's say Thomas created a website and started selling things, all right, or started uploading videos on his website. So he's going to get just 10 requests a day in the first month, okay, 10 visitors a day. But in the second month, it will be 200, and in the third month, it will be 10,000, etc. Okay, so EC2. So if he's going to rent a classic, he's going to rent a machine in a classic way, he will rent, for example, a machine that will allow him to be able to accept 1,000 requests a day, or 200 requests a day. It will be good. It will be good for the first, second, third month, 4th month, in 6 months, 9 months. But in 1 year, it will be not enough anymore. So he will change. He will need to take out that server and buy another one and host or deploy his application or his website again on another server. All right. So to avoid that, EC2 allows you to pay as you go. So if you use computational power needed for 1,000 requests, you will pay for that. If you use less, you will pay for less. That's why it's elastic, all right? So you pay what you consume, all right? And with that, we avoid our application going down. So if it goes up to 1,000 requests, the EC2 will allow it to go up to 1,000 requests. If it go up to more, the EC2 will allow it to take more. If it goes to less, the EC2 will allow it to go down and it will adapt itself to the number of requests coming onto your server. All right, and we had many stories actually of. There was a startup that had a very funny story. They were developing their platform for long, like for months, and they had investors and they had some money, and they decided to deploy their servers and start selling. All right. So on D1, like on D-Day, like the day they deployed their application, they went to sleep, and the CEO woke up in the morning to find out that the startup is broke. Because they hosted on AWS and they used EC2, all right? And they had in their code, I don't know, they had a hole in their code that they didn't test well. That's why it's so important to test your code. So they didn't handle this case, and the application was trapped inside an infinite loop or something like that. All right, and it was running all night long and consuming money all night long, and going bigger and bigger and bigger and bigger and bigger until the credit card was empty. All right, and all the money was gone. So he texted the guys from AWS, and he told them that they are now in, like, he told them what happened and that they didn't mean to have such code in their application, etc. And the customer service was very, very, very welcoming, and they just gave him back his money, all right? And I think they even gave him some months for free or something to start their business in a good way. So what these guys forgot to do is in AWS, like in EC2 and in AWS, there's a limit that you can put to your EC2 to not go over. All right. So people in Amazon, of course, are aware of this, and they implemented this feature, but the people from this startup didn't use it. All right. So actually, deployment it's not that easy. It's very critical, okay? Because you're playing with money first, and second, you're playing with users. So if your server goes down for one reason or another, or your server is not secure enough, you'll turn into big problems. All right.
And I'm pretty sure that was a really tough day for the developer that made that error.
Yeah, I think in the end they got rid of the intern.
All right. So we have here a question from Lauren, and we have almost 7 minutes remaining in our event. So Lauren is asking, what if you get attacked with unwanted requests?
Yeah, that's a very good question. So if your server means gets attacked, so he's talking about something that we call the DOS attack. DOS. And DOS means deny of service. Okay? It's when you get, it's like these guys, they made a DOS attack without knowing. So it's like when you send hundreds of thousands of requests to a server per second, so that server is not able to handle them, so it goes down. All right. So if you are using, sometimes there are websites for ticketing and stuff like that, and they tell you the tickets will be available at 9 p.m. But when you go at 9 p.m., you find the server down. That's because hundreds of thousands of people are trying to purchase tickets at the same time. All right. So they perform the DOS attack without knowing. Okay. But the people behind the application of the ticketing application or the ticketing system, they didn't expect that number of requests. All right. Here in Tunisia, actually, we have a website for universities for studies that you need to do subscription every year before going to the university, like to do it online. So it works fine, 11 months a year, but on the first month of the new scholar year, it goes down. Like whenever you try to access it, you find it down. And people have been complaining, please find a solution for this. And you can just pay extra money to make it more powerful and handle more requests, because you have many students in Tunisia and the country. But of course, the government is not paying attention to this, because they are saying we are going to pay money to, for example, accept 10,000 requests a second. So it's going to cost us money, but it's going to be beneficial for us only for 2 weeks or 1 month a year. So what would we do for the 11 months of the year?
They didn't hear about the EC2, I guess.
Yeah, of course. Actually, they don't hire people good enough, I guess, unfortunately. Yeah. So, and there's another kind of attack, it's called the DDoS. That's where the groups of hackers collaborate. They have multiple machines. Every hacker have multiple machines, and they start sending requests. Like it's distributed deny of service. So it's the same as DOS, but instead of being done from one machine, it can be done from separate machines at the same time. All right. And one thing I was going to mention earlier is that we said that instead of renting a machine, a whole server, you can just nowadays with virtualization, the service providers, to make more profit and to augment their profit, they make virtual machines, all right, on their servers, on their devices, and they sell you just the virtual machine. All right, so they have a machine, a computer of 8 gigs of RAM. You want just 1 gig of RAM. So they make you a virtual machine with 1 gig of RAM and they ship it to you. So yeah, that's the current situation now when it comes to deployment and hosting.
All right, so thank you them for this enlightening explanation about how does the internet work. So do we have any questions from our attendees?
I'm expecting a question, how does the internet work?
Oh, I think we not all at the same time, please. All right. So I think we don't have more question. So thank you everyone for your time and for attending this great event presentation. So people are saying thank you in the chat with smileys and stuff. Very nice. So thank you then for your time. I hope we can thank you. So I hope we can maybe have some other events in the future for different topic. Maybe we find the solution with DigitalOcean and make the workshop that we were supposed to do today. So yeah. So thank you everyone, and
thank you so much for your attention, and I hope it was beneficial for you all.
It was, definitely. So thank you very much, everyone, and hope to see you soon. And for our students, see you around in Discord. Have a great evening, and see you soon. Bye-bye.
Thank you.